Okay, so where we left off in the last videos, we were looking at the common ion effect, right? We found it here. We added sodium acetate to an acetic acid solution. That shifted the equilibrium this way. The concentration of hydrogen ion went down. We did the same thing with HF, except this time, instead of adding the conjugate base, we added more of the hydrogen ion. We add the hydrogen ion in the form of a completely dissociated HCl. That goes here. The initial concentration of this goes up, but this goes down now because we're shifting the equilibrium in this direction. We can do the same thing with bases, so let's look at those next. I've got ammonia plus water going to ammonium ion and OH minus. Now, this is my initial concentration, so we're going to look at what is the concentration of our ions before we add any of the conjugate base, or conjugate acid, I should say. So what we're going to do is we're going to find out what the pH is, or what the concentration of these are when I just have this in water. And then, what is it going to be when I add a little bit of this to it? This plus this. This should shift the equilibrium in this direction, which is going to change the concentration of the acids and bases that I have. So Kb for this expression will be NH4 plus times OH minus gives NH3, right? And if I want to calculate this, I'm going to go ahead and do the Rice table for this one, because bases, I think, for whatever reason, are just a little bit harder for students to see. So I've got Rice right here. My initial concentration is 0.2 molar. This is 0, this is 0. This is minus X, this is plus X, this is plus X. This is 0.20 minus X, but remember, I don't need to worry about that because my Kb is so low, and X. So again, I'm going to have X squared divided by 0.20 is equal to 1.8 times 10 to the minus 5. That means that X, which is equal to the concentration of hydroxide and the concentration of ammonium ion, is equal to 1.9 times 10 to the minus 3. So remember, this is the concentration of my OH. So I first can get my POH, which is 2.72, and then my pH is 14 minus that, which is equal to 11.28. Now, for this one, so there's the pretty high pH. What we're going to do for this one is we're going to add some ammonium chloride. So I'm going to take some ammonium chloride, which gives NH4 plus and Cl minus. This will become a spectator ion. And this right here is going to go right there. All right? So if I add this to that, what's going to happen to the concentrations? So if I add NH4 plus here, okay, I add that here, what's going to happen to this concentration? Well, it's going to go up just because I'm adding it. But what's going to happen to that? It's going to go down because I'm shifting my equilibrium in that direction. So this one's going to go down. I add this, shift the equilibrium to the left. All right? Now, let's see what the new concentrations of them are. So I'm going to prepare a solution. I'm going to mix them together. I'm going to take 500 milliliters of this one and 500 milliliters of this one. Notice that it was 1 molar of 500 mils, but if I add now, it's 1 mole in 1,000 milliliters, which cuts this in half and cuts this in half. That's my initial concentration because this is here and this is here, right? So when I do that, Then this is minus x plus x plus x, 0.50 minus x, but I don't need that. And 0.50 plus x, but I don't need that. So this is 0.50 and this is 0.50. So Kb is equal to the concentration of hydroxide, so I'm 0.50 divided by 0.50. So the concentration of hydroxide is equal to 1.8 times 10 to the minus 5. Notice that that is 1, so this is equal to Kb. I should have put that there, but anyway, this is equal to OH minus, and all of that is equal to Kb. So that means that POH is equal to 4.74. If this is the negative log of this is the POH, and it's 4.74, then the negative log of this is the same. So this pKa, this 4.74, is equal to the pKb. Again, it's when these two numbers are identical, and we're going to see this over and over again. So the pH of the solution is equal to 14 minus 4.74, which is 9.26. Notice that, what did I do here? I went from a pH of 11.28 down to 9.26, because basically what did I do? I added the ammonium salt, shifted the equilibrium in this direction, and the concentration of that went down. Because the concentration of that went down, the pH went down also. And so the pH of the solution with the common ion, it makes sense that it's lower than the pH of the base by itself.